Okay, everybody, welcome. It is 4 o'clock on Wednesday. Time for class to start. Um, I realized that I kind of hit you with the fire hose on Monday. I went fast because I felt there were a bunch of things I needed to cover and get you started on. So, what I want to do is take a little bit of time today to go a little slower and try to explain some things that in more detail. Hopefully, that'll get you really started and up to speed on Python. Um, okay, so I just put a note out on the GitHub, this additional file, some notes for today that we're going to walk through. Not a huge deal. The first thing I want to do is talk about what's in the course syllabus and explain how we're a little bit different than the other sections. If you've been on Discord, you might have already noticed that. If you haven't been on Discord, not a big deal. But I want to guide you through some of the things we're going to cover. So this is our version of the syllabus. It's a little bit different from what you will find in the majors versions of 201. The course overview is the same because, again, the course content's the same. The objectives are the same. The grading criteria is going to be the same. I think I put the old version in the last slides. Ignore that. This is what we're going to do. You have homework 0 assigned. It's 10 points, and we'll talk again about that. It's due. You have another week from midnight tonight, so you got a week and about 8 hours to do it. Then there will be 6 other homeworks worth 50 points each. You will have 3 major programming projects worth 100 points each. You will have 12 labs, the first of which is out there, worth 10 points each. Now, 2 of your 10 points for the lab are connected to attending the discussion section, so being with your TAs, and we'll talk about that. Attendance is right now mandatory for the labs because you have to work with the TA to prove that you've done the work yourself. Nobody else has done that forward. But at the same time, you do get to drop 2 labs without penalty. So if you miss a lab, not a big deal. There are 2 midterms and a final. We've reduced the value of the tests. It used to be that the 3 tests combined were 400 points. Now, as you can see, they're a little bit under 300, just about 270. So they're a little bit less, but we've got the more emphasis on programming, less emphasis on tests. Now, my tests, let me go back to the slides. My tests are going to be online on Blackboard in real time. The major sections, you may see some discussion of this already. The major sections are partly online on Blackboard and partly their take home, write this program and submit it in 3 to 4 days. I don't like that. I'd rather I don't want to criticize other faculty members. They do it their way. I do it my way. I want you to sit down. 90 minutes later, you're done with the test and you can move on. The final, obviously, 2 hours, sit down, 2 hours, you're done with the test. That's the way to go. There's no take home. I also do not use Respondus or the lockdown browser or anything else like that. I understand this is an open book test. I used to prefer to give open book tests when I taught back in the day. Use your notes, use your tests, use Google, look up anything you want to look up. You could either answer the question or not. Okay, so that's my kind of tests. Unlike the major section, which will include a take-home component, ours will not. They will be straight, sit down on Blackboard, start 90 minutes or 2 hours, done. Okay. In addition, another difference between our class and theirs, I will lecture this live at 4 o'clock from 4 to 5:15 every Monday and Wednesday. I will, as we've seen, post the videos. I record them, and I post the recordings on my YouTube channel. If you have to miss class or you want to go back and see something, that's fine. The other classes are not doing that. Eric Hamilton's classes, he goes live on YouTube for one of his lectures, and you can post a question in the chat. And the other lecture, you can watch the video later on. Dr. Wilson, my understanding is she's just posting all of her videos, and you can watch them whenever you want. That's fine. I don't criticize other professors. If that's the best way for them to teach, that's the best way for them to teach. Me, I like to be live. I like to be interactive. So that's how our lectures will work. These lectures will be live Monday and Wednesday, 4 to 5:15. You have to miss, that's not a big deal. I don't take attendance. You don't lose points to videos. Did someone have a question? I'm sorry, I can't hear whoever's speaking. Okay, no problem. If you have trouble and you want to say something, put it in the chat, and we'll watch the chat as well. Not a big deal. Again, there is no lecture next Monday, September 7th. That is Labor Day. You don't have to interrupt your weekend to get online from 4 to 5:15. There is no lecture. We'll take care of that. Once labs start, this is like majors courses. You're expected to attend until it takes, as long as it takes you to get the assignment done. Then the TA will check it off. You get 2 points for showing up, the other 8 for the actual lab assignment. So that should be fairly easy for you. I think most people get the lab straight out. On the topic of labs, I want to clarify something. I did assign homework 0 and I made a proofreading error. Proofreading didn't show the fact that that homework assignment says you've already done lab 0 and you can use that. Okay, you haven't done lab 0. There's no lab this week. Apologies for not proofreading better, but you don't need it. Homework 0 gives you everything you need in the instructions to do it, and we'll talk about it again in a little bit. So don't worry about what it says about lab 0. Lab 0 has been put out. I put a notice on the on Blackboard, and there's a long and detailed assignment description on GitHub. All Lab 0 is log on to Discord, make sure it works, and send a message to your TA. Okay, that's if you haven't logged on to Discord successfully, this will walk you through it. So the Lab 0 assignment talks about how to use Discord. Okay, it's all in there. It'll tell you what the screen looks like when you launch Discord. You should get something like this. You'll see a pop-up. You'll be invited. Our Discord server is called CMSC 201 Fall 2020. Professor Hamilton, Eric Hamilton, goes by the ID of Eric the Prof on the Discord server. He's the course coordinator. He's the one who drives what we all do. He hosts this thing. You'll see a screen like that. Then you have an invitation in your email already. You create the account, create it using their online form. Don't worry about joining another server. You're not. You're just adding this one. So Lab 0 shows how to walk through and join Discord. I know a number of you have already joined Discord. You've already logged in because you sent messages. That's great. Lab 0 just says, hey, ping your TA and let your TA know you're here, and then we're good to go. So that's Lab 0. That is the new one. So getting back to this slide, to the assignment. Proofreading error in homework 0, the homework 0 assignment says, oh, you've already done this in Lab 0. You haven't, but you don't need anything else. You can do everything with homework 0. Okay. Don't worry about what it says in lab. Do the lab. Both the lab and the homework are due next Wednesday. You have a week. If you want to be able to enjoy the weekend, do them ahead of time. If not, you don't have to rush. With respect to homework 0, I will walk through things just a couple more times. Homework 0 is log on to the UMBC Linux server, gl.umbc.edu. Okay. Um, if you're on a Mac, which I am right now, and I promise I'll get my Windows laptop in here sometime. If you're on a Mac, you start a terminal. Okay. If you haven't seen this before on a Mac, you go to Launchpad, you select Other, Terminals under Other, you click Terminal, and this brings up a terminal window. And now you're good to go. Okay. So when you bring up a terminal, this is what it looks like on a Mac. It tells you what your computer name is. In this case, it's Alfred's MacBook Pro. It tells you what directory you're in your Mac. In this case, it's on my home directory, which is called Alfred Arsenal, because I have no imagination whatsoever. And now I'm getting a command prompt. I'm getting asked to type a command. So in this case, from the Mac, I'm going to type SSH, that is secure shell. SSH, your email address, in this case, Arsenal, just the name, not the @umbc.edu, your email address at gl.umbc.edu. Okay? If you do not put your email address, it will use the default ID you have on your Mac. We're talking Mac here. I'll talk about Windows in a second. But if you do not say, I want to use Arsenal at gl.umbc.edu, it will take your username on your Mac as default. And that will cause a problem because, again, as I said, on this Mac, my username is Alfred Arsenal because I got no imagination. It will try to log me into gl.umbc.edu as user Alfred Arsenal, and there is no such user. Okay, there's no account for that user, that name, and so it will fail. So you have to, if you're using a Mac, you have to give it the email address at gl.umbc.edu. Then you'll be prompted for your password. Now, this is key, both Windows and Mac. As you type your password, you'll notice nothing is echoing. It does not give you dots. It does not give you asterisks. It does not give you any indication that it's hearing you type. That's okay. This is a Linux server, and that's just how Linux works. So don't worry that it doesn't look like it recognizes your typing. Just type your password. And again, this is the same password you use for your email account, right? When you're logging in for your email account at UMBC, this is the same password you use at GL. After you've typed your password, hit enter. I may have made a typo there. We're going to find out soon. Yeah, I typed wrong. No big deal. This time I got it right, and that's how you log in to GL. Now, if you're on Windows, the difference is, as we mentioned, you have to download and use this application called Putty. And when you start Putty on your Windows, it will pop up a box. It will pop up a window on your screen and ask you for the system name. The system name is gl.umbc.edu. It will ask you for a port number. The default will be 22. Just make sure 22 is the port number. And it will ask you which protocol you want to use, and you want to make sure SSH is clicked. gl.umbc.edu, port 22, and SSH. Then you click Connect on Putty. Then what will happen is a window will pop up on your Windows screen, and it will ask you for your username. So that's the difference between Mac and Windows. On Mac, as I said, I had to give it my username. I had to say arsenal@gl.umbc.edu. On Windows, you do not do that. You just say gl.umbc.edu, and then it will ask you what's your username. And then you just enter your UMBC email address, whatever it is. In my case, my last name without the T, Arsenal. And then it will prompt for the password. And just like on Mac, when you're typing your password on Putty on Windows, it's not going to echo anything. You're not going to see any dots. You're not going to see any asterisks. That's not a big deal. That's fine. It's listening to you type. If you type it wrong, just like with me, it's going to tell you that's wrong, and it'll give you a chance to type your password again. So that is how you log in to gl.umbc.edu so you can do homework 0, this 10-pointer. Once you've got that logged in, once you've got your logged into GL, you just need to know the commands. Now, again, GL is Linux. It's a command line. There's no clicking windows. There's no anything like that. You just type commands at the line. Okay. So remember that to create a directory, the command you type is cd. So we tell you in homework 0, make a new directory. CD is change directory. Create a directory is makedir. MKDIR says create a new directory. Make a new directory, and it's called CMSC 201. Well, I've already got that created, so I'm going to call this demo CMSC 201. It's exactly what you'll do in homework 1. You'll make this directory, except it's not demo underscore. It's just makedir CMSC 201. Create it. Now I can change directory into, and it would help if I typed correctly. Okay, what did I do? I misspelled it. Okay, it gives you, it's the error messages in Linux are not real great. You will get used to them. It's not a big thing to overcome. Okay, so now, and you can see by this string over here, it tells me what directory I'm in. I'm logged in as Arsenal. I'm logged into this Linux box. I started out in my home directory, tilde means home, and now I have moved into the directory demo CMSC 201. This is what you will do. You will move into your CMSC 201 directory. Now we tell you create 2 more subdirectories, labs and homeworks. Make dir labs, make dir homeworks. Okay, if you want to see what you have, in Windows, you can look at the directories, the contents of your directory. You can see what's out there. In Linux, you just type ls. ls is a list, and it shows you that I have 2 directories. I can tell they're directories because they're highlighted in blue. That means they're directories, not in files. If I want to, there are other things I can do to tell they're directories, but I created them. Okay. Now in homework 0, we tell you to change into your homeworks directory. Remember, change is cd, change directory. Okay. Okay. Sorry, just checking the chat. Yes, I'll get to you. Yeah, the TAs are exactly correct. I'll get to that in a second. But yes, Jeff is 61 and Tommy is 62, and they both put information out. And yes, SSH does stand for secure shell. Okay. I move into my homeworks directory. PWD is print working directory. That tells me where I am right now, and I can see that I'm in the homeworks directory. Now, we do make you use an old-fashioned text editor called Emacs. I mentioned last time, I think it was first created in 1972, so it's about 50 years old. But it still works, it's just ugly. So you can create a new file, and it will look something like this, Emacs hw0.py. This tells me to open the file homework0.py in the Emacs text editor. If the file exists, it'll open it. If the file doesn't exist, it'll create it. Okay? When you go into Emacs, you will get something like this. Okay? And now this is a text editor, and now you can type what we tell you to. Okay? So that is how you get started in Emacs, and If you think bash commands are ugly, you have seen nothing yet. We force you to learn the hard way. You will do things like Control X, Control S to save files, and so on. But that's what it's going to look like. And I'm going to close this terminal right now. And that is how you get started in Homework Zero. So again, the Real Lab Zero is out. It's just to make sure that you can log in to Discord, find your section channel, and introduce yourself to your TA. And Homework Zero is out. Don't worry about the fact this is all you've already done this in a lab. You have not, but it's fairly straightforward to do. By the way, these are the identical homework and lab assignments that the majors are doing, so you can watch and see what they're doing as well. In terms of the teaching assistants, great. You anticipated. Awesome. Jeff Martin is the TA for section 61. Jeff is aware that attendance is not mandatory next Monday, Labor Day, September 7th. So in his room on Discord, he will put out information for you and instructions. Again, since the lab is only a matter of saying, hi, Jeff, this is who I am, it's not a big deal. He'll get in touch with you. Tommy Nguyen has section 62. So you will meet with Tommy next Wednesday, just long enough to say hi. What their duties are, how we do them in CMSC 201 as TAs, they run the labs. When you go to your lab section, they are the ones in charge. If we were physically on campus, they would be standing up in front of a room full of computers, walking you through the assignments and helping you with any programming issues you have. That is what they will do here. They will teach you the lab material in your discussion section each week. They will cover what's new in lab, which is typically just writing some Python programs that demonstrate what we've covered in lecture. They will help you with your assignments, labs, homeworks, and programming projects. They will help you with them. They have regularly scheduled office hours. They will let you know what they are. In addition, you can go to any other TA during the other TA's office hours. But again, Jeff and Tommy will know directly who you are, what you're doing, and why. So that might be a good place to start. And in fact, that since they get paid the outrageous sum of I'm being facetious here, they get paid basically Maryland minimum wage. They do a lot of the grading. I grade all the exams. That's just a personal idiosyncrasy of mine. I want to grade the tests, but all the projects, the homeworks, the labs, Jeff and Tommy are going to grade them with instruction from me on how to do it, with me being the final arbiter if there's a problem, but they'll do that. So those are who your TAs are, and you should make sure you get to know them because they are really great at helping, and that's what they do. And both of them are really enthusiastic, and I've been very lucky. Last semester, I had two really good TAs, Anna Yashchenko and Jordan Malcolm. This semester, Jeff and Tommy, I've got two more really good ones, so this should work well. As I mentioned last time, office hours are on Discord. They have a voice channel. The way you do it is you log into Discord, you go to the requests room and enter a request to talk to a TA. There are 27, if I remember correctly. It's about that 27 TAs for CompSci 201 because there's like 600 students. So there's around 27 TAs. There are multiple of them on duty at any given time. So when you go and enter a request, whoever is on duty and is next will take you in the queue. Now, wording right for homeworks are due, right for programs are due, right for test time. They're going to be really busy. You may have to wait in the queue for a while, but they will take care of you. They will address it. They can do it by exchanging text. They can share screens. They can look at your code. They can set up a voice channel. That's why we're using Discord. Again, your own TA, Jeff and Tommy might be good to start with them first, but you can go to any other TA in this class. Okay. So that's TAs. Let's see, what else did I want to talk about today before we get into more hardcore Python programming? I've already showed you that there's a new lab zero out. I've already showed you more about logging on to GL. And now I want to talk about comments, since you'll see this in homework 0. A comment, remember, is something, a line of code. It's a bit of Python that nothing happens about. It's all an interpreter. And the standard comment in Python is a hash or a sharp or a pound, whatever you want to call that character. And that's, anything it sees from there to the end of the line. Once it sees that pound sign from there to the end of the line, it ignores it. Python interpreter ignores it. But we tell you in homework 0, you have to have a block comment, where the comment is a bunch of lines. If you want to do that, you could use a whole bunch of pound signs. You could write a comment that says pound, this is a comment, pound, name, Larson Alt, pound, section, 65, don't show favoritism, pound, assignment, HW0, pound, etc. You could do this, and this is one way to get a block comment, a whole set of lines of code that will be ignored. But that's awkward. It doesn't look neat. It's ugly. You have to fool around a little bit with lining everything up, getting everything in order. So there's a neater way to do that, and that's with triple double quotes. We'll get into why later in the semester. We'll get into exactly why it works this way. But for homework 0, this is what you need to do. You have a triple quote, triple double quote, not a single quote. This is a triple double quote that on a line by itself. Then after that triple double quote, you can type anything you want, however you want to type it, format. I've typed the text. This is how you type a block comment in Python. I spelled Python with a capital Y. Let me fix that. And then eventually I end with a triple double quote on a line by itself. Now, this is PyCharm, which I talked about Monday. If you've already got it downloaded and installed, this will look familiar. If you haven't got it downloaded, if you're not going to, not a big deal. Don't worry about it. This is just an illustration. This is my text editor box in PyCharm where I can write and save and edit code. I've done it here. And you see that I have this block comment, and then after it, I have the Python command that we talked about last time, print hello world. So what I'm going to do is I'm going to highlight this whole block of code. I'm going to copy it. I'm going to paste it in the Python console. So in this bottom left corner, remember, is a Python console. It will run a line or a block of Python code as soon as you type enter. So you can test things. You can see how they run, so you can demonstrate it. So I just copied the code from the comment of the code from my edit box into the Python console in PyCharm. You can see I have a block comment, and then I have the command print hello world. I hit enter to execute it, and all I get is hello world gets printed out. A nice thing about Python is if it's a comment, it will gray it out and print it in italics. The fact that it's grayed out and printed in italics lets you know it's a comment and it's ignoring it. If it's not supposed to be a comment, every now and then you'll have an error and something will be commented out that's not supposed to be. If you see code that's gray and italic and is not supposed to be, that's a hint. And then down here in plain black text, it has the command, and this is green, and that's because it's a value, and we'll talk about that in a minute. So all this is to demonstrate for you in homework 0, this is what we mean when we say we want you to write a header comment that is a block. It's in between these triple double quotes, these sets of 3 consecutive double quotes right next to each other. And so that's what you'll be doing in homework 0, to write your header comment that has your name, your section, the date, the identity, and what have you. Okay. Warning. If you actually write your code in Word or Pages or some other program like that, and you save it as plain text, it doesn't save it as pure plain text. And so what happens is if I write a program in Word, because it's a good text editor, and I copy into Python, these quote marks right here get replaced with Microsoft or Apple smart quotes. And smart quotes are not legal characters in Python, and you get all kinds of error messages. So if you're creating your program in this edit window of PyCharm, we're cool. If you're creating your program in some other editor and you think you're saving it as plain text and it doesn't work, check it out carefully because it might have saved it as smart quotes, and that's why it might not be working. Just a pointer there that happens a lot. Okay, so that will tell you about logging on to GL, and that tells you about comments. Again, since Monday, all I talked about was a single line comment, which is a pound sign followed by whatever to the end of the line. In homework 0, we ask you to type block comments, and you will go ahead. If you're doing it directly at Emacs on homework 0, that's fine, straightforward. But that's how you do it, is with these triple double quotes, particularly on a line. All right. And this is an illustration, basically what I just showed you in PyCharm. Okay, so now hopefully we've helped you a little bit understand a little bit of the fire hose that came at you Monday. In terms of the class and how it's going to be structured, the syllabus is out there. I don't mean to give the syllabus short shrift. It's all there. It has all the information on academic integrity. Don't cheat. If you have not experienced it before, there is a site on the web, on the internet, called Chegg, Chegg. Chegg is a place where you can go to get help with your program. You ask people, and if you have a membership, you pay, and they will help you solve your problem. If you don't pay, you get a free membership, and you get less help, and what have you. And if you want to be a programming expert, you can sign up as a Chegg tutor, and they pay you $20 an hour, and it's not worth it. You can help people cheat. We don't like to do this. The bottom line is, as I said, in the majors classes, Hamilton and last semester Johnson, this semester Wilson, gave take-home programming projects. And the day the test was issued, people took the programming assignments and went to Chegg and said, hey, how would you write this program? What happens then is, yes, we do monitor Chegg. We do other things as well. And we find out who posted the program, who posted the homework problem on Chegg. And you just failed the class. And you get to explain why you get to remain a student to you at UMBC, and maybe they'll let you and maybe they won't. And anybody who turns in the exact solution that whoever on Chegg gave you gets a 0, and then you're not going to do well. So please don't. By putting the tests on Blackboard and giving you 90 minutes, you really don't have time to post it on Chegg and get a good answer fast enough. They don't work that fast. So that's one of the reasons I do this. But at any rate, that's a sidebar. Let me come back to topic. All right. So now I want to get back into programming Python with the 40 minutes we have left in this class. I tend to be long-winded, as you've seen, so I have to make sure we're not going over. This was something I talked about having a whiteboard to do last time on Monday, so I'm going to sort of do this. So what does your computer's memory look like? This is pretty much what your computer's memory looks like. It is a long array of individual boxes where you can store things. You can store bits, you can store long strings of 0 and 1s in these things. This is memory. I can click in here and I can store the value 6, and now the value 6 is stored in memory. I can click in here and I can store the value hello. Sorry. Let's try that again. I can store the value hello world in this location in memory. So this is simply what your computer memory looks like. It has you can consider it to be a very long list, a very long array of places where we can store bits for later use. That's all it is. Now, every operating system is different. Mac is different from Windows, is different from Linux, is different from OpenBSD, is different from whatever. It doesn't matter for our purposes. But your particular computer, your operating system, has an identifier, an address for each location in memory. In most cases, it's going to be a very large number. So, for example, this location in memory, your computer may call that the number 452.549.7152. And this location may be 452.549.7184. So each of these is a location in memory. It has an address that your computer knows, that your computer references. You say in this location, 45 blah blah 152, store the value 6. And in this location, blah blah 184, store the value hello world. This is what's happening as your program is executing. You're storing values in memory, and then you're retrieving them so you can do something with them, and then you're putting them back. Well, this is really ugly for you to have to know what these memory addresses are, what these numbers look like. I mean, for the most part, there's just no need. Yeah, for some people there are. But for this class and for most people, there's just no need to know what this is. So the programming language hides that from you completely. And it does it somewhat like this. There is a data structure, a way Python has of storing values called a symbol table. Now, what a symbol table is a mapping of things you use in your program to locations in memory. So let's say you have a statement in your program, your Python program, that references the value X, and you say, I have something called X, set the value of X to 6. What happens is Python, you don't have to deal with this. This is all behind the scenes. Python's doing it for you. Python says, when Al says X, he really means memory location 452.549.7152. So when Al says put the value 6 in this memory location, we can do it. When Al says put the value 6 in X, go put the value 6 in this memory location. When Al says put the value hello world in Y, right? All I have to do is I've got something called Y. I want the value hello world put there. The symbol table says, Al means this location in memory, 452.549.71984. So therefore, Al, go put the value hello world in this location in memory. That is what's going on behind the scenes as your programming is as your program is working. Python creates and manages the symbol table. You do not have to worry about it now. That keeps track of all the things you use in your program and maps them to these hideously long addresses in memory where it stores values and it can retrieve a value. Okay, so keep in mind that that's what's really going on behind the scenes. Now, you check chat real quick. If you're in the Monday section, you're in 61. If you're in the Wednesday section, you're 62. And if you don't remember whether you're in Wednesday or Monday, ping me after class and I'll let you know. You're in lecture section 60. Your discussion section Monday is 61 and Wednesday is 62. Okay. That being said, let's get back to Python programming. Now, I rushed through this, languages, Python, why Python, Okay, GL, fine. Let's go to where I was. Okay. Now, back before this. Talked about comments. Okay. This is where we started talking, and I probably confused you if you haven't done any programming before. Apologies. Now we're going to try to make it clear. In your Python programming, and we're going to look at examples in just a second, you have variables. A variable is just a symbolic name that's associated with some value that's associated with a value stored in a location in memory. Okay, so let's say in my Python program, I have the statement x equals 6. What this statement does, this is a Python statement, specifically it's called an assignment statement. It says, take the value 6, the number 6, and store it in the memory location associated with this variable called x. So you have decided I'm going to do something in my program that requires the value to be 6 to be stored somewhere. I'm going to call that thing where it's stored x. Now, go back to the other chart, right? Python says, now Python, you do not have to declare variables before you use them. If you haven't done any program before, don't worry about it. Ignore that statement. If you have done programming in another language, Python does not require you to define a variable before you use it. The first time you use it, it gets defined. So Python says, this programmer had a statement x equals 6. Grab a location in memory. This one is free. How does it decide where to grab? How does it decide what to do? We don't know. We don't care. Not relevant. Too dependent on the operating system, the computer, what else is running, the time of day, the phase of the moon, and everything else. Don't know and don't care. Okay. All we know is that Python finds an empty location in memory, takes its long numeric address, associates it in the symbol table with the statement that you used, x, and stores the value 6 right there. X equals 6 results in the number 6 being stored in this location in memory, and Python saying anytime this person uses the variable x in this program, we will use whatever is in this location in memory. Whatever's in this location of memory is what this person means by x. Okay, and that's all a result of this assignment statement. X is a variable. Formal definition. It's a symbolic name. Yeah, okay, symbolic name. X, your algebra, whatever. It's associated with the value. It's associated with whatever is stored in that location in memory. Okay. Variable, the word variable means it can change. So that gives you a hint as to why we call these things variables. The variable means the value can change during the program's execution. Okay. I said x equals 6. Okay. Now I'm going to have another line of code, and I'm going to say x equals. All right. I need to make this bigger so I can click in it without wiping things out. I'm going to have my next statement in my Python program to say x equals x plus 1. Now, from our math days, from algebra in high school or whenever you took algebra, you understand what that means. X equals x plus 1. What does Python do? Python goes back to its symbol table and says x is whatever is in this location in memory. This location in memory has the value 6. Retrieve it. Add 1 to it and put the value back in this location in memory. Now, this location in memory has 6. I add 1. I put the value back. That location in memory now stores 7. That's why X is a variable. It can change. Okay. So X is just a name. It's a symbolic name. Don't worry too much about what that means. It's just a name that's associated with location and memory, and it can change during the program's execution. Okay. And what this statement says is just what we talked about. When you use a variable in Python, the Python interpreter goes and grabs an empty location in memory. How, why, we don't care. We don't know. Too many, dependent on too many different things. It associates that variable's name with that location in the symbol table. We don't care how the symbol table works either. Just Python manages that for us. Then any value assigned to that variable are stored to and read from that location. When we said X equals 6, we put 6 in that location in memory. When we said X equals X plus 1, we said fetch the value in that location. It's 6, add 1 to it, doing standard algebra. That gives us 7. Put the value 7 back in that location in memory. That's all variables are in Python, is they let you change things throughout the program execution. Okay. We don't always have to have numbers, integers, whatever. We've been doing 6. I can put, as I've shown on the other slides, I can put hello world in that location in memory. I can do that. That's fine. Whatever I want, it's just bits. It's all internally represented as a string of ones and zeros, and something figures out what those ones and zeros mean. Python handles all of it for us. Okay, so that is what we mean when we say in Python a variable. We're going to use that as part of our program. Skip that mess from last time. Python has some rules about what kind of symbolic name you can use, what kind of things you can use in your program. Your variable name must start with either a letter or the underscore character. Okay, the underscore character, you know what that looks like. Okay. You cannot start a variable name with a digit, and you cannot start a variable name with any other special character. No question mark, no $, no hyphen, no period, no nothing, right? Underscore or a letter. Uppercase letters, that's cool. Lowercase letters, that's cool. Yes, Python is case sensitive. Python is case sensitive. A capital X and a little x are two different things. They're two different locations in memory. They're two different variables. Okay. Use them both. We'll talk about how and when in the class. Okay. You can't start a variable name with a digit, but you can include a digit in the name. Once you start with either the letter or the underscore character, you can have a variable name that has uppercase letters, lowercase letters, digits, underscores, what have you. In the name, as long as they don't start it. Again, case sensitive. It's important. Okay. We'll get you a handout, which I should have already, I just realized right before this class I haven't put out. We do have a set of course coding standards, things we want you to use, things we want you to do. Okay. There's additional rules, but for Python, these are the rules that count. This is all Python cares about. Start with the letter or the underscore. Can't start with a digit. Include uppercase, lowercase, digits, and underscores. No other special characters. And case sensitive is something you have to deal with. So those are Python variable names. So the first question, is the variable name OneSpam in Python, is that a legal variable name? Anybody? Correct. It is not. It is not legal because it starts with a digit. Raise 1, is that legal? Absolutely, yes. The next one, spam and eggs, is that legal? Absolutely, that is a legal variable name. Starts with a letter, the fact that it's capital doesn't matter, and includes only letters and underscores. Could include digits, it doesn't. Exit underscore code, exclamation point, is that legal? Absolutely correct. No, because these exclamation points are not valid in Python variable names. So those are examples of what you can and can't do. Okay. Now, I sort of beat around the bush with this last time and didn't do a very good job, so let's take our time and solve. What we've just talked about are variables. Values that we've talked that we use in our program that are exact values are called literals. A literal is something we want Python to use this exactly. We do not want Python to create a location in memory and store a value for this. We don't want it. We want something that is this exact value. So going back to our example here, this is PyCharm again. And in our Python console window, you notice that hello, comma, world is in green. That is in green because this is PyCharm's way of telling you that this is a literal. PyCharm, the Python interpreter, understands that this is not supposed to be a variable. It's not supposed to be something else. It is supposed to be this exact string, those characters, hello, comma, world, with a capital H and a comma and a blank space and everything else. That is a literal. And as I said, PyCharm will be nice and highlight it in green for you to let you know that this is a literal. Now, when you say print hello world, Python doesn't go grab a location in memory. It doesn't store anything associated with hello world. It doesn't do any of that. It just says use this exact string encoded as a bunch of bits exactly like you said. That's what it's going to do with that. So that is a literal. Now, we'll get into some more details later, but foreshadowing hello, comma, world is what's called a string literal. The number 3 is a literal. The number 6 is a literal. When we said x equals 6, that says take that literal value, take that exact value 6, and store it in that location in memory. Okay? So when I say x equals 6, x is a variable name, 6 is a literal, and that's the value that will be stored in that memory location associated with that variable. So 3.14159 is a literal, 2.71828 is a literal. These are other literals. Literals can be of various types: integers, floating point numbers, real numbers, and strings. Okay, we'll get to that in just a minute. I'm jumping ahead of myself. In programming, we use the concept of a constant. Now, what a constant means is that I want a location in memory to store something, but it's never going to change in my program. So going back to my memory location, I'm going to have a statement that says pi, pi, equals 3.14159. That's a valid Python statement. What's going to happen now is Python will grab another location in memory. It will associate it with pi. It'll create an entry in the symbol table. And in this location in memory, it will store 3.14159. Okay, and I'll have an entry here in the symbol table for pi. Okay, now we say constant because these things are variables. Constant means we do not want it to change. I mean, the value of pi should never change. Okay, my first master's degree was from Purdue, which is in West Lafayette, Indiana. And there's an old joke that's actually a true story that about 1900 or so, somebody in the Indiana state legislature decided that having pi be this irrational number that never ends is too hard for the future farmers who are going to school in Indiana, and it would be a whole lot easier if pi was equal to 3. And so they actually introduced a bill in the Indiana state legislature to change the value of pi to 3. That's actually a true story. Fortunately, the joke is a Purdue math professor happened to be visiting the Indiana state legislature on that day, and sat down with the fine, august members of the legislature, explained to them that pi was a constant and you can't do that. So it goes on as a funny story because they decided not to do that. The point of all that being that pi is a constant. We don't ever want the value to change. The legislature doesn't get to declare it equal to 3. Okay. So in Python, we have this notion of constants. It needs a location in memory. We're going to use it, but it will not change. Here's the ugliness. Python, if you've had other languages, you might have seen constants, you've done things. Python cheats. Python does not understand what a constant is. So when we're teaching you programming and we're teaching you in Python, we have to cheat here. We tell you that if you want it to be a constant, if you never want it to change, declare it in all caps, which is why I spelled pi in all uppercase on that other slide, right? That means to me, it's going to be a constant. I don't want it to change. I want to understand it. But guess what? Python doesn't enforce that at all. If you make a mistake and later on in the in your code you decided that the Indiana legislature was correct and pi should be changed to 3, it will actually work. So we teach in this class the concept of constants because they're important and they're supported in a lot of languages. But we have this minor problem that Python as a language doesn't actually support them and enforce it. So we enforce it through coding standards, which is you declare a constant to be in all caps. It looks just like a variable, except it's all caps. And then you follow the rule of never changing it in your program. If you screw up, you might change it and it will work, but we as people reviewing your code will go, no, that's an accident. Please don't do that. So it's important that you understand what the concept of a constant is. It's important that you understand how a constant is different from a literal, and it's different from a variable. But we have this problem that Python doesn't really enforce it, so we just sort of cheat. Apologies, but that's the way we have to do. What is the difference between a constant and a literal? This is always exam 1. One of the questions looks like something like this. What is the difference between a constant and a literal? A constant is a name, symbolic name. A constant represents a location in memory. A constant has an entry in the symbol table, and there's a location in memory that stores the value you assign to it. A literal does not have a location in memory. It's not a name. A literal is just use this value. In my statement, pi equals 3.14159, in my statement here, pi, pi, is a constant because it's all caps. 3.14159 is a literal. Use this exact value. So that's an important difference to understand. What's a variable? What's constant? What's a literal? Variable, it's a name. It represents the location in memory. It's got a value and it can change in the program. Constant, it's a name. It represents a value in location in memory, and it's not going to change in the program once it's set. Okay? Sorry, skipped a slide. The next slide is a list of reserved words. Now, there are rules for variables, and obviously, since constants aren't real, the rules for constants are the same as for variables, except that you use all cap letters. Python has a series of reserved words that mean specific things. Every language, be it human language or computer language, English, Chinese, German, Python, C++, JavaScript, you have 2 components to a language, semantics and syntax. Semantics refers to what I mean, what I'm telling you to do. Turn in your homework. That has a semantics. It means you need to submit by the deadline. Okay. X equals 6. That has a semantics. It means take this literal value 6 and store it in whatever location of memory you have associated with X. That's the semantic, what it means. Semantics, what it means. Syntax is how I tell you. There are rules. I have to use things that you understand. If I use words you've never heard of, we're not going to communicate. I can't be offensive. If I use words that mean something else and that are offensive, you're not going to pay attention to what I'm telling you to do. You're just going to get upset because I'm a jerk. Okay. Semantics is what I mean and what I want you to do. Syntax is how I tell you in the rules. So the syntax of Python includes reserved words, words that Python has already declared a meaning for, and you cannot redefine them. Okay. You cannot use any of these variables, any of these words, pardon me, as variable names. And in this course this semester, we will gradually work through what each and every one of these words does. Can't start all, or you'll be really case sensitive, really fire hose, and we're not going to do that to you. Okay. What these are is these are things that have special meanings. You cannot use them as variable names. You cannot use them as constant names. They are case sensitive. This is very important. The word false, capital F, little a, little l, little s, little e, that is a reserved word. It has a specific meaning in Python. Little f, little a, little l, little s, little e, that is not a reserved word, and you can use little f, little a, little l, little s, little e as a variable name if you want. I recommend you don't. It's going to be confusing, but you can. These reserved words are case sensitive. So you might, for now, we'll explain what each of these words means when we get there. But for now, if you use a reserved word as a variable name or something, you're going to get an error message, and we'll deal with how to recognize that and get there. Types. Variables and constants have defined types that determine what you can do on them. For now, we only care about 4 types of variables and constants. Integers are whole numbers, positive, negative, and 0. Okay, whole numbers, you can do math on them. That makes sense. You can do math with integers, and integers aren't good for anything else. That's cool. Float. The Python term for a number that's not an integer, that's got a decimal point and something after the decimal point, is a float, a floating point number. This is something you might have been taught is a real number or something else, but it's a float in Python. It has an integer part, something to the left of the decimal point. It has a decimal point, and it has something to the right of the decimal point. Okay. And you can do math on floating points, on floats. Now, the math you can do with floats and the math you can do with ints are a little bit different, and eventually we'll get to that. Because if you divide the integer 1 by the integer 3, that's, going to have some interesting results as compared to, say, the floating number 1.0 divided by the floating point number 3.0, and we'll get there. But for now, integers, you can do math. Floating point, you can do math. A slightly different set of math, but it's logical. Strings. A string is 0 or more characters treated as a whole. When I said that hello world is a string literal, that's exactly what I meant. It's a string. It is 0 or more characters, in this case, HELLO, comma, space, WORLD, 12 characters, all treated as a single thing. That's a string. So hello world is a string. It's a literal because you use exactly that value, but it's a string. It's 0 or more characters. And I really do mean 0 or more characters. You can have something called an empty string, and we'll have examples of that. The last type we care about right now is Booleans. If you've done, depending on what kind of algebra or calculus you've had in your background, you've done a lot with Booleans. Booleans are true or false. 0 or 1, true or false, A or B, whatever. Okay. So Booleans can have 2 values, true or false. Now go back to the previous chart with the reserved words. The reserved word true, TRUE, is a Boolean value. The reserved word false with a capital F is a Boolean value. Those are the only 2 values that Booleans can have. Little f, Nope, not valid. Little t, nope, not valid. Just true and false. Okay. So let's go in and do some programming and show you how we work with more of these things. Okay. Let me get a new Python console to clean off that old stuff. All right. So let's make sure before I get going, I make sure we've got all the questions addressed. Yep, don't see any questions. Please feel free to ask. This is why we're going live. It's for you to ask questions. Python console. I'm going to assign a integer value. Let's call it I. I equals 6. Why not? Now, we can do the basic math, and Python works pretty much as you would expect in terms of math. I want to say I equals 6 times 3. Okay? This statement assigns a value 6 to stores a value 6 in some location of memory that's associated with I. This one will do the math. It will do 6 times 3. The star character, or the asterisk, if you want to call it that, is the multiply symbol in Python. This is going to do 6 times 3, and it's going to put that in the location that's associated with I. So now, in a Python console, if I want to check the value of anything, I just type its name. What is the current value of I? Well, if I say I, PyCharm will print out the current value, and lo and behold, it's 18, which it should have been. It did 6 times 3. Now, the value of I used to be 6. Doesn't matter. That was overwritten. That's gone. This statement superseded that, so this is 18. That's the value of I. I is, of course, an integer. I said before, you don't have to declare a value in Python, a variable in Python before using it. You just use the value, the variable name, and Python figures it out. Now, in terms of types, Python also figures out its type from what you've said. I is an integer. I didn't have to tell Python I is an integer. By the fact that I assigned it an integer literal value 6, or the fact that I assigned it an integer literal value 18, that was enough to tell Python, hey, I is a variable and it's an integer, so go grab a location in memory and put an integer there. Now, what if I want to add 1 to it? I can say I equals I plus 1. Now, these spaces are not important. I could be leaving out spaces. I'm using spaces between things to try to illustrate exactly what I'm typing. But I could just as easily go I equals I plus 1, and it would be equally valid. So spaces, don't worry about them. This is just me doing it because I'm comfortable trying to illustrate. Okay. Now, what this statement does is it says, go to memory, grab the value of I. The value of I is 18. We saw it right here. Grab the value of I, 18. 18 plus 1. This is an integer. We can add plus 1. That's a perfectly valid operation to do with integers, adding 1 to it. And now, store the value back in I. So the value of I, we hope, is 18 plus 1. We better hope that I is now 19. And lo and behold, it is. So we've written this Python code that says, put this value here. Now let's use a constant. I'm going to say, I don't know exactly, but I'm going to declare a constant that has the number of students currently enrolled in Comp Sci 201. Okay, last fall, for bizarre reasons, I still remember this. It was 559, so let's say that's the right number. It's in that ballpark. It's high 5s or low 600s. Number of students equals 559. Cool. Now, how many sections do I need? I'm going to say sections equal num of students divided by 20.0. Let's think about this statement. What is this going to do? It's going to tell me to go fetch the value in memory that's associated with num of students. Now, remember, internally to Python, this is the same as a variable, just logically, we consider it a constant. It's going to fetch that value, which is 559, and it's going to divide it by 20.0. Division, floating point division in Python is this slash. This slash means floating point division. So I'm going to take 559 and I'm going to divide it by 20.0. And I'm going to assign that to sections. Sections, therefore, Python's going to figure out, hey, I'm getting a floating point value. I have to declare a new variable. I have to go get a new location in memory, and it's going to be called sections, and it's going to store a floating point value. So we hit enter to execute this statement, and now we have a new location in memory. And that location in memory is sections. And if I want to look at it and say, what is the current value of sections, it's going to tell me it's 27.95. Okay, because it turns out with this division, that's exactly how it is. Two significant digits past the decimal point. If it was some other number, it would give me up to 15 digits of decimal accuracy. In this case, it only needed 2. So now I have done math. I've used a constant. I've done some floating point division, and I've stored it there. And now I can use my print statement to say, print the variable sections, and that's going to print out the value, 27.95. Remember where I used a string literal like hello world? If I said print sections, this is highlighted green because this is a literal. What it's going to do is it's going to print that literal. It's going to print exactly that because that's what a literal means. Print exactly this. Don't declare a location in memory. Don't go out to memory. Don't get a value. Don't do it. Use exactly this. Print sections prints that. Print the variable sections gives me the value, which is 27.95. Now, I've only got 2 minutes left according to my Mac, so I am going to stop there since we'd already planned to cover more of this next Wednesday. We're going to start talking more about variables, and we're going to talk about more complex Python coding. Homework 0 is out. Lab 0 is out. They're both due next Wednesday night. All the lecture notes I've dealt with to include more details, stuff that I'll get to next week. It's already out if you want to look at it. Don't worry about it. If you have any questions, let me know. If you can get on Discord, you can ping me. Please definitely, for your lab assignment, ping Jeff if you're in section 61. That's the Monday section. Ping Tommy if you're in section 62. That's the Wednesday section. Feel free to ping me or feel free to send me an email. If you're having trouble getting into Discord, email me, email your TA. We'll figure out how to get you there. If you're having trouble getting into GL, you can ask on Discord or you can send an email message and we'll get you there. That's about it. Are there any more questions, or I'll give you back 1 extra minute of your day and wish you a happy Labor Day? No? All righty. I am going to, okay, let's see, questions. Spaces do not matter in the, great, good question. Question, what data science project? Okay. At the moment, there's nothing I can share. I'll see if I can find some of the previous ones that I have done. My major project that I did for my master's, what we did was we took the Twitter garden hose, which is it's the set of all tweets that you're allowed to get free, which is millions and millions per hour. And we built a product that would search them all for indications of problems And we picked Southern Africa because one of my teammates had a company that was doing business there. And we looked for signs of any trouble. The news is not always great on there's a volcano eruption, there's an earthquake, there's a fire, there's an insurrection, something is going on. And so what we tried to do was parse millions of tweets per hour for signs of anything that would indicate we need to contact our employees there and tell them to shelter in place, leave, the coast is clear, whatever. It was a really interesting project. So it's pretty cool. And it was all written in Python, which was the neat stuff, except for the web interface. The web interface was JavaScript, but it was all, the rest was all Python. So anyway, okay. All righty. Have a good weekend. Get your lab and your homework done, and I will talk to you next Wednesday. Thank you.